Hi, so in this video on Idiomatic Python, I want to take a look at generators and how we should be leveraging generators probably a whole lot more than we already are. So we'll look at generator expressions first. We also have things called generator functions, and I'll come to those in the second part of this video. So generator expressions, like list comprehensions, essentially use the same syntax, this comprehension syntax. So let's take a look at an example quickly. And let's say that for this example, we want to get a list of numbers whose square root and cube roots are both integers. So to do that, I'm going to say from math, I'm going to import the cube root function. Now this is only available in Python 3.11 and higher. That's a new function they added, and square root. So we're going to use that, and then I'm going to use a list comprehension first. So this is just the comprehension syntax, and it's going to generate a list for us. So I'm going to want to generate a tuple that's going to contain the number, the integer of the square number, the integer of the cube number, whatever that happens to be. And we'll do this for I in range, let's say 2 to 100. So we'll pick, the first integers from 2 to 99 inclusive, basically, and find out where that criteria happens. So I have to put an if statement. So I'm also going to use the walrus operator to do the assignment to square root I. So square root I is going to get assigned to SQ, and so I can reference it back in this tuple over here. And if you don't know what the walrus operator is or how it works, I have a video on that in this channel as well. So we're going to want to make sure that this happens to be an integer. So whatever that square root was, we want it to be an integer. And we're going to want to do the same thing with the cube root. So I'll call it CB. That's going to be the cube root of I. And I want to make sure that that is also an integer. So basically the way I check that it's an integer, I look at the return value from the square root of I, and I check to see if it's the same as the integer of that same value. And by using the walrus operator, I do not have to repeat square root I over here or square root I over here. I can use that in this temporary variable. So when we do that, we can take a look at the list. We have exactly one number in there. Now let's say that I want the first 5 numbers, right? I only got 1. So in other words, in order to get 5, I'm going to have to increase that range. So I'm going to take the same code and let's go ahead and make that, I don't know, maybe 10,000. Let's do 10,000 and let's see what we get. So we'll look at that result. Okay, so it's the same code, nothing's changed. And now we have 3 numbers. 64, 729, and 4096. So that's good, that's 3, but that's still not enough. So we need to go higher still. And I have no idea how high I'm going to go. So let's do 100,000 this time. And let's see what we get. And we get 1, 2, 3, 4, 5. So that's it. So we've got the 5 numbers. All right, so okay, I've got the 5 numbers that I was looking for. But you notice how I ended up doing more calculations than I actually needed. I ran the loop 100,000 times, but I really only needed to run the loop 46,656 times. So I wasted some computations. If I'd done it a different way, I might have stopped as soon as I reached this number here, 46,656. Ideally, I would stop at that point doing any more calculations because I've already returned those 5 elements. But now, what if I wanted 10 elements? Well, again, I'm just going to have to take that same code and we're going to go now to, let's say, 5 million because I have no idea how many I'm supposed to calculate. So if we do that, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got 2 more than what I actually wanted. Right? So again, I did more calculations than I really needed to. But if I want to get the first 10 out of that, that's fine. That will still work. I can still do that because what I can do is I can maybe say results, all the results equals that. And then my list is going to be the results, let's say, and the first 10, like so. And if I look at my list now, once I fix my typo, you can see that I have just 10 in there. So there's a number of problems, right, with this approach. If I want the first 10 or 20 or 30 or n in general, I have no idea what that range should be. I'm either going to, choose a value here that's going to produce not enough results, or one that's going to produce maybe too many results. And even if I produce, if I happen to find the number that produces the exact correct number of results, I'm probably going to overshoot that by a certain amount and waste time doing all these computations. So if I have a program where I need to find the first n numbers, and n is a variable that comes from somewhere else, how do I approach that, right? That's a problem. Now, I could certainly go ahead and put in some huge number in here, right, to try and guarantee that I'll be able to cover the first n numbers no matter what, but that's still not correct, right? Because I could have a situation where that n exceeds the numbers, or I could have a situation where I'm just calculating way, way, way too much. Maybe the person only wants the first two in, the time when this program ran. The first time, somebody only wanted the first two numbers. The second time it ran, somebody wanted the first 10 numbers. And so I'm always going to be calculating more than I have to. So instead of using a list comprehension, we could try a generator expression. The main advantage here is that generator expressions only calculate one iteration at a time. So we're not wasting time or resources producing more results than we need. But still, we have this problem of having to specify the range. But it has no upfront cost, but that's still an issue, but we'll come back to that. So we could do the following. We could say results equals, and I'm going to take basically the same code that I had over here, right? But instead of using a list comprehension, which is the square brackets, I'm going to use the round parentheses, which is a comprehension for a generator. This is a generator expression. So when we do this, and I'm going to make this number huge, right? We said that we were going to try and fix this problem of not knowing how many to compute by just computing as many as we think we're going to need. So I'll do 50 million. Now, if this was a list comprehension, it would take, quite a bit of time to actually run. But as you can see, this code executed almost instantaneously. And that's because it's a generator expression. It hasn't actually calculated anything yet. It's waiting until it does so. So in order to actually get the results from this generator expression, we have to iterate over it. At that point, then Python is going to start running this code until it finds one element to emit, and then it will emit it and then stop processing. So if we want the first 10 elements, we just iterate over the results. Now it is a generator, so we can't slice it, at least not using regular slicing syntax. There is something that we can use in the itertools module. We'll come back to that. So all I need to do is just basically iterate over results. So I could do it this way. I could say next results for underscore in range 10. Right? So this is basically just, calling next on this results generator, right? It's an iterator, and I'm going to do it 10 times. So we do that, and we can take a look at what extract is, and it has our first 10 numbers. Now, of course, the generator has been iterated over. So if we want to restart, we're going to need to redefine it, right? Remember that just like with iterators in general, once you start iterating over an iterator, you can't go back, right? It always just keeps going forward until it finishes, until it gets exhausted, at which point there's not much more you can do with that particular generator. But that's okay, because creating the generator itself is very, very cheap. So what I'm going to do is I'm going to copy this again. We'll just have to reissue that same statement. And then I'm going to show you that itertools where we can use the islice function instead of using this approach that we had over here, which is fine, by the way. Nothing wrong with that. This is just a little bit more simple to use. So again, I'm going to recreate basically my generator. And now I'm going to islice it. So I can do islice results 10. Now islice is itself an iterator. And you'll notice that in Python 3, almost every function that you use to do iteration is basically going to be iterators. They are not going to be lists, right? Very rarely are functions going to return a list of elements to us. They're going to return essentially iterators or generators. Why? Because it saves the upfront time of doing all the calculations. So let's go ahead now and make a list out of that so I can actually see everything in there. So basically I'm iterating through islice. Islice is going to iterate through results until it reaches 10 elements, right? And so we get the exact same result. Okay, so this is a much better approach than the list comprehension because we're not incurring that upfront cost of all these calculations and the storage of those values, unless we actually need them. Here we only need the first 10. We're only going to run the calculations for the first 10. And we're not going to incur the storage cost of everything else beyond that. But we still have the issue of specifying that huge range, right? I mean, this is fine. We could make the range, some huge, absurdly huge number. Let's do 500. I don't even know what that number is anymore, what the name for it is, but it works exactly the same way and you're not going to incur any kind of performance penalty. If we do again the same thing, you'll see that it comes back pretty quickly, and that's because it only does the first 10. But this is not good programming, right? Because yeah, this is a big number, but who's to say that at some point in time, we're not going to exceed, we're not going to ask for so many results that it exceeds that number over here. So instead, we can use a generator function. So generator functions and generator expressions are very similar. They both essentially produce generators. The only thing is with the function, you've got a little bit more control over what you can do. So let's go ahead and create one. So I'm going to call this one numbers. And we're going to start with number equal to 2. And then I'm just going to do an infinite loop because I have no idea how many numbers I want to generate out of this generator function. So I'm just going to do infinitely many. And then the person that's using this generator can decide how many times they want to iterate over this particular generator. So we'll say SQ equals square root of number. We'll do CB equals cube root of number. And then we'll say if the square root is equal to the integer of the square root. So if it is an integer number and CB is equal to the integer of CB, so and the cube root is also an integer, then we're going to yield. And we're going to yield the number. We're going to yield the integer of SQ. And then, of course, I have to be very careful about this. I have to add 1 to my number. So basically, I'm starting at 2, and I'm checking to see if the square root and the cube roots are both integers. If so, yield that number and the square root and the cube root. And then otherwise, it's going to add 1 to it, and it's going to come back until it yields. Now, when it yields, it's going to pause execution, right? That's how generator functions work. And I do cover generator functions in detail in the Python deep dive series that I have on Udemy. So I'm not going to cover that in a whole lot of detail here, other than to show you how we can use this. Okay, so we have that, and numbers can produce essentially an infinite number of results. And now we can go back to using islice, and we don't have to. We could also just do a for loop over it. But here I wanted, say, to generate a list. So I'm going to islice the first 10 elements, and you'll notice that basically what am I doing here? I'm creating a new generator, right? I'm creating a new instance of this generator by calling the numbers function, which is a generator function. So, and I do this, why? Because remember that if I want to run this twice, then I'm going to need to always recreate the generator itself. So this gets done at the same time. Okay, so we get that and we get the same result. Now this is a completely general solution, right? We can take the same thing here, and now the next time I run this, I can say, well, I only want 3, and then I just get the 3, or I want 15, and we can do that. and we get the 15. So, although generators and generator expressions are single-use objects, they are cheap to create. So if you need to iterate through the same generator multiple times, you just recreate it, right? It's not a big deal and it's not a problem. The advantage is that generators do not hog memory to store all the results, and they do not incur the upfront costs calculating more values than we actually need. And you'll notice, as I mentioned a little bit earlier, that in Python 3, most built-in functions that are used for iteration are actually generators. Functions like zip and islice and enumerate and many, many more. All these are generators. And there's a good reason for that. And you should make use of generators and generator expressions a lot more in your own Python code. That's a lot more Pythonic. But there's even more that you can do with generator functions. It's not limited to that. You're probably aware of context managers. The most common one is the context manager we use to open and automatically close files. Whether we have, an exception that occurs or not, we're still guaranteed to have the file closed. And that's what context managers are about. So let's go ahead and let's create a file. Let's call it planets.txt. And we'll make that write because I want to write to this file. And I'll give it the handle F. So at this point inside this code block, my file is open. And once the code block exits, then my file will automatically be closed. And I'm just going to write lines and we'll put in some planets in here. And I'm just going to actually copy that from the notebook. It's linked below. And it's in GitHub. Okay, so I put in a few planets in here. Now, this file has been closed because it exited the context manager. Let's say I want to read the file back. Well, I'm going to do exactly the same thing. I'm going to say with open, except this time I'm not writing to the file. So I'm going to remove that. And by default, it's going to be read. So that's what I need. And then for line in F, so now I'm going to iterate through F. You'll notice another thing here. F is an iterator. It can read the file one line at a time. I'm not incurring the cost of loading the entire file into memory. In this case, it's a small file. It doesn't matter. But imagine that you're working, let's say, with a CSV file that's got, billions of rows in the CSV file. Do you really want to load everything up into memory just so you can process things one line at a time because you need to move the data somewhere else or do a calculation on every row? No, you don't want to incur that cost. And so this way of opening files also gives us this iterator approach, right? This generator approach on reading files. Far more efficient. So now we can do a print, and I'll print that. And then since I already have new lines in the file itself, I'm going to set my end on the print to just be an empty string. And so this is the contents of the file. Now you'll notice that we did not need to close the file, right? That happened automatically once the context manager was exited in both cases. Now we can write our own context managers using a generator function. And to do that, we're going to use a generator function and also the context manager decorator that's in the context lib module. So from context lib, I'm going to import the context manager, okay? And that's a decorator. And let's start by writing a context manager skeleton, just a very simple one. Doesn't do much, but that's okay. We just want to see how that works. So we'll do the decorated function, and I'll call this one echo. And I'm going to do the kind of the standard skeleton. We try, and then we do something. So here I'm going to actually just print entering context manager. Then usually we yield. So we yield a result. If no errors have happened in our try block so far, then at some point we're going to yield. And here I'm going to yield a lambda function. And the lambda function will be a function that takes in a single variable. And it's just going to say echo says. And then I'm just going to interpolate whatever you said back. Right? So a very simple function that just basically returns what you said prefixed with echo says. Now, if there was any kind of exception, right? So except exception as EX. So if there's any kind of exception, I'm going to print an exception occurred. We may want to handle it or not. And this is inside, of course, this function. And I'll just interpolate what the actual exception was. And I need to close that off. Okay. And then finally, this is the important part, because finally will always execute. Whether the try finishes, whether this function finishes and the try finishes properly, or an exception occurs, finally is guaranteed to run. So I will say print exiting context manager runs whether an exception occurred or not. Okay. So this is basically kind of the skeleton for any kind of context manager that you're going to write in Python using the context manager decorator. Now, there are other ways of writing context managers using classes and special functions. I'm not going to get into that here, but basically you can do that without using this decorator approach. But using a generator function makes it relatively simple. Okay, so let's use it. Let's say with echo. So I'm going to call echo. I'm going to get a function back, right? That's what I get. When I call echo and nothing goes wrong, I yield here a lambda function. And so that's what's going to happen. When I call echo here with the context manager, it's going to run echo until it finds this yield, and it's going to return that. And I can now assign this to whatever symbol I want over here. So I'm going to call it func. And now that I have this, well, func is what? It's a lambda function. It's my echo function, right? So I'm going to say print func hello. And what I'm going to do here as well, let's do it a second time. Let's do it this way first. Let's not actually cause any errors to occur. So we'll call function hello and then function by. Okay? So you see what happens? We're entering the context manager. That's what happened with the with statement, right? Then we called echo twice. So that's why we got echo says, and then the code exited, the code block for the context manager finished. So at this point, we're exiting. And so this finally gets executed, exiting the context manager. And of course, this will happen whether we have an exception or not. So let's go ahead and do that. And instead of calling this function twice, I'm actually going just to raise an exception over here. So something's going wrong in my context manager code block over here. And you'll notice that the exception was trapped. Let's go back and look. That's the problem with trying to make this code big enough so that people don't complain that it's too small to read on their phone. If you're trying to run this on your phone and trying to learn coding by using your phone, you're probably in the wrong channel. Anyways, so what's happening here? Well, we got the value error that we raised inside our context manager code block over here. So it got trapped over here. As you can see, this wrong value got sent over here. So it was received here. And then we still did our finally block. We still have exiting the context manager. Now the exception could even be caused by that returned function itself. The exception could be happening right in here. It doesn't have to be something that happens in this code. It could be something that's happening maybe in this code over here. So let's do another one. Let's say context manager def square, and let's try. And again, we're going to print, actually I'm going to take this whole thing as is, and I'm just going to change what my lambda does. So lambda is just going to return x times x, okay? So nothing's changed except for the lambda function, and now we can actually cause a problem to occur in the lambda function. So let's just make sure it works. So with square as func, we're going to print func10. So that should work, no problem. We enter the context manager, that's happening here. we print the square of 10 and then we exit. So we exiting the context manager, right? If I had more code over here, print done, right? You would see that we get that in this order as well. Once we have code that's outside of this with block, then we've essentially exited the context manager, right? So we get the exiting context manager. Now, if I try and now force an error, that's going to happen here. Maybe I pass it A, then again, right? The exception occurred. It occurred inside that function that was defined over here, right? But the exception still basically bubbled back up to the context manager. It was caught here. And then the finally, of course, still happens. Okay, so this is how the context manager works. The context manager decorator works with a generator function. Now let's do something a little bit more practical with it. When we read and write CSV files, we can use the CSV module. So let's start by creating a CSV file. So I'm going to import the CSV module, and I'm just going to copy this code from the notebook that's in GitHub, right? So I have a headers, first name, last name, and I have some data, Isaac Newton, Gottfried Leibniz, and so on. And I'm going to now write a CSV file. So I'm going to say with open, and we'll do test.csv. And of course, we want to do a write, right? We want to write this file out. So we'll set the mode to W. And then I'm going to create a CSV writer, which is going to be a csv.writer. I'm going to use the writer from the CSV module. I'm going to pass it the open file F. Then the CSV writer, I'm going to write a row. And to write a row, I just pass it basically a list or a tuple or whatever of items that I want to write as a row to the CSV file. So here, I'm going to write the headers. That's the first thing I want to write. And now I want to write out my data. There's a couple of different ways I could do it. I could use a loop. I could say for row in data, and then I can just use the write row, just like we saw just now, CSV writer.write row, and then I'll pass it the row. So we could do it this way, and I have that in the notebook. Another way of doing it, and it kind of depends on, if there's any other work maybe that you need to do before you write the row. Maybe you need to do some transformations first or something. In this case, I don't need to. So I could also just say CSV writer dot write rows, right? We have that, and I can pass it data like so. So now that we've done this code and run it, we actually have a CSV file. We can just go ahead and see what's in that CSV file. So with open test.csv as F, we're going to print, and then I'm going to read everything at once. It's a small file, so I can read all the lines into memory, essentially. But of course, usually we don't. We use the iterator approach, one line at a time. In this case, it doesn't matter. And here's what I have in my file. Now, of course, we can open that file using a CSV reader. So again, just like we saw before, we're going to say test.csv as F. Then I'm going to make a CSV reader by using the CSV.reader. I'm going to use the reader function that's in the CSV module. I'm going to pass it this open file F. And then I'm going to read one row at a time for row in CSV reader, and we'll print the row like so. And so as you can see, we recovered the data from the CSV file. Now you'll notice that every time we want to write a CSV file, we need to open the file, right? So when we're writing, we need to open the file, which we do with a context manager. Then we need to create the CSV writer. We need to do whatever we want, and then we have to close the file, which of course the context manager is taking care of for us. And then the same thing with the reader, right? When I'm doing the reader, I have to open the file, create the reader, do what I want with the reader, and then close the file. So we could actually combine this into a single step using a custom context manager. We have a context manager for the file, but I'd like one that does both opening the file and creating the reader or the writer. So let's do it this way first. Let's go ahead and say context manager. And I'm going to call this CSV reader. That's going to be my context manager name. I'll pass it the file path. So it's not taking an open file, now it's taking the file path. So I need to open the file. I'm opening it for read, so I'm just going to do a straight open. And then what am I going to do? I'm going to yield CSV reader of F, right? That's all it does. Now, do I need to trap exceptions? Well, I'm not going to do anything with an exception if I get one, so I'm not going to catch an exception. But what about the finally? Don't I need the finally? Well, what would the finally do? It would basically just have to close the file. I don't need anything else here. But this context manager is already going to take care of that. So that's it. I don't need to do anything more with my CSV reader. That's it. That's my context manager. And now I can use it this way. I can say with CSV reader test.csv as reader, and then we're just going to basically go through every row in reader, and we'll just print the row like so. And I should call it reader, sorry. And there we go. So we've got our data, right? And we didn't have to do the separate with open and then creating the reader. We just did with CSV reader. Now we can do exactly the same thing with the writer. So let's go ahead and write that. So again, context manager and CSV writer. And again, we'll pass it the file path. So that's all it needs. Now the only difference here is I need to open for writing. And in this case, I'm going to specify W. So it's always going to be recreating the file from scratch, not appending. And then what do I do here? Well, I just need to yield the CSV writer. And we'll give it F. Okay. And again, I don't need to worry about closing the file. So I don't need the, to do a finally here. I don't need the try finally because the with open file is already going to take care of that for me. So that's that. And now I can just say with CSV, and let's write test2.csv. So I'm going to create a file and I'll call this writer. And I'm just going to say writer dot write row. And then we'll write one row containing A and B, like so. Okay. So that now created this thing. I can read it back with my CSV reader. So reader, and again, we're going to do test2.csv as reader, and then we'll say for row in reader, print row, okay? And what did I do wrong? Reader, row in reader, okay? Like so. And so we just read the data back. Now, of course, we can combine both of these into a single context manager, because if you think, they're really very similar, right? We're doing pretty much the same thing. So let's go ahead and write that. So context manager, and then I'm going to call it CSV file, and we're going to pass it the file path. Now, the only thing is here, I need to know the mode, and I want to require people to pass that as a, a named argument. So I put the star to indicate that I do not have any more positional arguments, and now I've got a mode, and I'm going to default the mode to R. And we're going to do this. We're going to say if mode is equal to R, and I guess I should be consistent with using single or double quotes. If mode equals R, then we're going to say with open file path as F, and then we're going to yield a CSV reader on F. Otherwise, I'm going to say elif mode in, and then I'm only going to support W for write and append. I'm not going to support any other mode when I'm dealing with CSV files. So here I'm going to say with open file path as F, and I know there's different ways of doing it. I could have collapsed everything in with a single open statement and then just yield the CSV reader or the CSV writer. I just chose to do it this way so I can separate the logic a little bit better, or a little more clearly, right? So I'm going to open the file path, but of course I can't just open the file path in read. I need to use whatever mode was passed in. So this is what I was saying, right? I could have said if mode in read in RWA, then open file path, comma mode, and then if it was R, then return a reader, otherwise return a writer. I could have done that. And then else, I want to raise a value error. I'm going to say, no, I have an unsupported mode, must be one of read the R, W, and A, like so. Okay, so that's my context manager. Now I can go ahead and write a file. So I can say with CSV file, let's call this one test3.csv, and let's say our mode is equal to W as writer. Oops, writer. And then I'm going to say writer.writeRow, and I'm going to write 3 values, A, B, and C. So I'm just going to use the list ABC, and I'll write another row. So let me save myself some typing. A, B, C, D, E, F, let's say, like so. So now I've just created this CSV file, and of course I can now read it back using the same context manager, except this time I'm going to say test3.csv. I'm not going to specify the mode because the default is to read. So that's going to return me that reader that I want. And then I can say for row in reader, print row. And we get ABC and DEF. Okay, so of course this is just one example of using a context manager. Now, oftentimes, context managers are used with databases, for example, to start and commit or roll back, if there's been an exception, transactions, for example. That's a very typical use of context managers. But as you write code and you find yourself having to do this, when something begins, I need to set some things up, then I need to do something, and then at the end, I need to tear down those resources, whether or not there were exceptions. That is a context manager that you should immediately think context manager. And for that, you can use generative functions pretty easily. If you grow beyond the generative function to use, as a context manager, then you can certainly go back and actually do a class-based context manager. But this video was about generators in Python and how you should really be leveraging them more in your code, both with generated expressions and also, if you need to, generative functions. And of course, generative functions have additional usage above and beyond just not calculating things, ahead of time. All right, thanks for watching.